Okay, great. So at this point we have been able to create the volume, right? If we go back to the diagram, we've been able to create the ingestion schema. We've been able to create a volume. We've been able to create a bronze, silver, and gold schemas as well. Now we need to create the JSON and the CSV files, right? Now we need to create the JSON and CSV files. And for that to be done, we need the data that we will be populating into the CSV and the JSON files. And I already have a data collection, a data set here. I already have the data here. And this is what we are going to look. We will have two data sets, one for orders. If you go back to the diagram that we had, we have orders table and customers table, right? So I have data set for orders, and it will be two CSV files for orders and two JSON files. Two JSON files for orders and one CSV file for customers. And from that, we'll be able to tell we'll take a look at the data. When we take a look at the data, we'll be able to deduce some things from it, right? So let's go to the first data set. And to get all these data sets and everything, I've created, uploaded it to a link in the description below, right? In the description of this video, go there and download the data for yourself and all the code base, right? You'll have every code we used here in that file. So if you go there, you can download it and then use it for your practice. All right, let's take a look at the first order data. So we have orders badge 1. Orders badge 1 has orders ID column according to what we have here. Customer ID, same thing here. Product, category, quantity, unit price, order TS timestamp, and status. This is exactly the same as what we have here, the diagram we do here, right? And we can see that it has all the fields that we need. The same thing applies to orders batch 2. It has the same field as we stated in the table, right? It has that. And so let's take a look at the data set for orders batch 1. This is the first batch of the orders. We can see some data sets are missing, right? We have customer IDs. Now maybe during the entry into the system there might be a glitch, or it was not a required field, but we need it to be able to get some data from it. So the customer ID is missing, right? So you can see also a part of it has negative quantity, which we can see a -2, right? -2. And we also have, this is a duplicate of order number 1003. So you can see order number repeated, right? Order, the same order was repeated twice. That's duplicate. That means this order, you can see it highlighted it for me, so it tells me this and this are the same, so it has repeated, right? That's a duplicate. All right, we go to order 2. You can see they said broken date format. It has a broken date format. Now look at the dates here, right? And look at the original dates that we have here. You can see that the format is different. The format here is very different from what we have, right? It's very different from what we have. And as such, and we can also see in this same order batch 2, there's a duplicate of 1009. This is also a duplicate, another duplicate in here, right? So you can see it's also repeated, right? So these are the two data sets we have for the CSV for the order. It means maybe these orders happened on two separate days or two separate periods, right? So we would capture them into the volume, right? According to this diagram, we'll capture it into the volume. All right, let's go back. And also we have the customer. If you come back to our diagram, the customer table, we know we have customer ID, name, email, city, sign up date. If we go back to our cell, we are making this a CSV data, and we know this the CSV needs a header, right? If you are pushing data in this way, you need to state the header, especially if it's CSV. So we have the customer ID, the name, email, city, and sign up date. So if you go there, is the same as what we have here. Great. So this is what we have. Now let's create. What we are going to do is to create, according to this diagram, always the project architecture is what is guiding us. That's what is going to guide everything that we are doing. That is why I keep referring to the architecture, because we are moving according to how the architecture is designed, right? That's how you process it, right? Because the architecture will serve as a guide to you on how to implement it. So you always have to be referring to the architecture to ensure that you are meeting the requirements or what you designed that you want to do. If you want to make a change, make it at the architecture level, and so you get a broader overview of the impact on everything that you did before you implement it. That way you are able to see errors in the architecture faster than implementation, right? You catch some pitfalls faster than when you begin implementing. So now we need to create this CSV and JSON file and load them into the volume, right? So let's go back, and then let's create another text and say load. Let's create and load JSON file into volume, right? So we're going to create and load the JSON file into the volume that we have, right? We're going to create and load it into the volume, this volume that we created. And if we go back to the table, we can see the volume is the landing, right? The landing volume that we created. So let's go back and let's ensure our serverless is started, right? Okay, so now to do this loading into the volume, we are going to use a Python process, right? But we use a Databricks utility, right? Databricks Utils. It's already inbuilt property that we can use. So let's just Google and check the documentation for Databricks Utils. So Databricks Utils. So you can see over here, it's already telling us Databricks Utils, which is dbutils, are built-in toolkits that lets you interact with your Databricks environment directly from Python, R, and Scala notebooks. So they are inbuilt stuff that you can make use of, right? You can make use of that Databricks already has. You don't need to recreate them and all that. They already have the components and everything that you need to just make use of it. You just call it and make use of the utils part of what you want to do, right? And this is the documentation that you can check here, right? There are a lot of Databricks utils that you can make use of, but in this we're just going to make use of some aspect of it, which is the Databricks FS put, right? Databricks FS put. If we go back to this, you can see Databricks FS here. File system. That's the file system. Databricks file system allows you to manipulate file and objects stored directly. You can read, write, copy, move files, and mount cloud object storage. So you see, this is what we'll be making use of. We'll be using a file, the Databricks file system utils, right? So that's what we'll use to put the JSON, to create a JSON from this data, right? We'll use it to create a JSON from this data. Then we'll push that data into the volume that we have here, right? So the serverless is running. Let's ensure that everything we have here is running. So let's run the volume again, so that Databricks, now you see, because I had to take a break and come back, the serverless went off, so it doesn't recognize this variable anymore. So I have to run the variable again. I have to run the variable again and run this volume again, right? And run this again, and choose to run this again. Run this now. Now you can see that we've been able to debug it and the bug is gone. Now this would create a dictionary of list, right? This is a dictionary containing list of items, right? So we can run this, and then we have the variables. So these are variables we've assigned these dictionaries, right? Let's run it. Let me see. Okay, it's done. Now let's make use of the Databricks utils, right? Databricks utils, creating and putting the JSON files. Okay, to do that, if we go back to the sheet, we can see it said we should call Databricks dbutils.fx, right? So what we'll do is dbutils.fs put. Put is going to tell us that, okay, Databricks file system, like, take this JSON and dump it in here, right? Like, put it in this part, take this data, put it in this file and all that, right? That's what it means. We open bracket, right? Open bracket, then we open brackets. Then what happens is, because we will be calling the landing part in there, right, this variable, you know what to do. F string, we need to bring F string this way. Then we have the landing part. We can go back and get the name, grab the name, right? The landing part, and we know the landing part means just this location. So it's telling us that go to this location, right? And this is the location, this landing, right? This location, comma, when you go there, create a new folder called orders, right? Orders, create a new folder called orders, comma, Then you create a new file in this folder. When you go to that path, create a new folder called others. Then within the others folder, create a new file called others underscore 2026. We're creating this JSON, right? This JSON, right? And we want to use the date as the medium of knowing that this transaction took place this date. We'll say maybe the most recent date that this transaction occurred within this file. So we want to just say 2026 0702 dot JSON. So create this JSON file, right? In this others folders, create this JSON file in this others folder, comma. You can choose to continue or maybe come to the next line, right? You can come to next line. I just want to ensure that next line, because we are moving to the next line, we need to bring that annotation for that Python is aware. Dot join into bracket JSON dot dumps, right? Right, for a for loop for every O in others in this variable. For every others in this variable, what should it do? So we are telling Databricks, this is a Python code, that create others folder and create this JSON file. Okay, then when it creates the JSON file is empty. When it creates this from the onset, it's empty, right? Now we tell it that, okay, JSON, okay, take this, create a JSON file. Now you dump every loop when you walk through this variable that we have, and we know the variable is this data set. When you go line by line, that's looping for loop for every data that you see within this file. What you do is you drop it into this JSON file that you created, and that is what we are going to use override, right? You overwrite it equal true, right? So what it's saying is, anytime you loop through this and you loop through that data and you are pushing the data in, right? Anytime you are pushing the data in, what you need to do is, if you even see that there's already data within this file, overwrite it. Just overwrite it. Don't consider the fact that there's already data in it. Just overwrite it. So let's run it and see. Saying there is an error in this. Okay, so maybe think this, yeah, this was the error that we had. This was the error. So hold on, let me go back. Okay, we didn't need this bracket, so okay, I think there was something wrong else. All right, this should take that out. I think it's this. Okay, syntax error. Undetected command line 3. Dot JSON join. Let's see. I think this comma shouldn't be there. Yeah, this shouldn't be there. And I think JSON dot join bracket open JSON dumps oh sorry, I got it. We need to import JSON. Yeah, import JSON. Okay, got it. Yep, got it. Great. So we needed to import the Python library or the property, right? We needed to import the JSON object, right? The JSON library, right? Before we could make use of it. That's why it was referring to me that JSON not found and all that. All right, great. So this has been done, right? So let's go back and see what happened here. Let's refresh and see what really took place here. Nice. So if you see this, we were saying that you should create orders folder and it should create this JSON file. So let's see if it created a folder. So this is the orders folder in the London volume. If we open it, we should find perfectly. We should find the orders, the first batch of the orders file. So this, you can see the size. It means the data we pushed in, which was this batch, first batch, truly got updated, right? It got updated. If we add extra data to this JSON, it would update it, but the update wouldn't be like to attach the new data. No, it would override and like it would delete the whole data in that JSON and re-upload every data again. That is why we have the overrides here, which is true. It's just a matter of delete everything in that file and put it again. But this time it will come with extra data. That means if we update this JSON with a new set of data, that's what the override does. It doesn't just push the new data in there. It just it updates everything. So that's what happened. Now, what we need to do is to create a second JSON file, which is batch 2 as well. So let's create batch 2, right? So let's create batch 2. Because we already imported the JSON library here, there is no need to import it here because already the serverless is aware that we've already imported it, so I don't need to import it. All I need to do is to grab this. You can copy and paste this here, but in this case we are going to change. We know this is going to have a different name, right? The date is going to change, so this one we will call it, because it cannot be the same file name, right? JSON file name. So we'll call this 4. Then we know the badge for this is badge 2, right? So we change the badge to 2 and we run it again. This is also done. If we refresh, we should find the second JSON file in here. If we refresh, Then we open the others. Now you can see that we have the second JSON file in here, right? But this uploaded the second data set, this data set in it, right? Great. So that is how we've been able to create this objects, this JSON file. So if you go back to our diagram, we've been able to create the JSON part of it. Now we need to create a CSV part of it, right? We need to create a CSV part of it. Let's go back to our code. Then we begin and say creating the CSV data, right? All right, so with this, we know this CSV belongs to customers. So in our landing place, right, if we go back, we have orders folder. We need to create a new folder which will be for customers, and then upload or create the CSV, the customer CSV in that folder. And we already know how that got placed done. So we say db Databricks Utils dot file system dot put this in it. So f string, again we have landing underscore path slash. In this time around, we will not say orders, we will say customers, because it's going to create a folder customers in the landing path. And we know the landing path, based on what we did, would be this, and that will be in the landing volume, right? So create customers folder. Now create a customers dot csv, create customers dot csv file, right? And in the customers dot csv file, what data should be added in there. If you create a file, then take this data, which is customers.csv. What should it do to this data when it takes it? The same thing that we had here, overwrite it, right? Overwrite equal true. Sorry, comma. Overwrite equals true, right? Overwrite equals true. Then we run this. Great, this is done. So if we refresh, we should find customers dot, we should see a new folder which is customers folder, right? So let's refresh. We see customers folder, we see customers CSV. Great, so both folders have been created. And now if you go back to our diagram, we've been able to create a CSV and JSON files, and we've loaded the CSV and JSON files into the volume. Now this ingestion part, this data source part is done, ingestion part is done, all using Python PySpark, right? So we can see that this part of the project has been achieved. Congrats, that's great. Good, you followed me to this level. It means you are practicing, you are learning. Make sure you practice this, write it on social media and share with me, tag me. You'll find my social media handles in the description of this video. So we've been able to achieve this. That is good job. And you can see that even though the data had issues, right? If you take a look at this, there might be some issue. Now we can see this repeated, right? Duplicates in here. This also had some duplicate. We did not intend to clean anything at this stage. We loaded the data just as it was, right? Just as it came through. And that is the beauty of Medallion Architecture, right? You do not edit right from the onset. No, you do not clean it. You maintain the originality of the data, right? The next step that we will do is to load this data from the volume into the bronze as well, right? Okay, at this point we've been able to create, if we go back to the diagram or the architecture, we've been able to create a volume and create the JSON file and the CSV file. We are at this stage where we need to load the files into the bronze layer, right? So the bronze layer will contain the raw data that is found in the volume, the CSV and the JSON files would be loaded into a table, a schema, which is the bronze schema with their various table names, right? Going back, so let's create that. Let's load the data that we had in the volume, which is the orders. If we go to the orders volume, we have two JSON files. We are going to load them into this schema, which is the bronze over here. We're going to create load these two into this bronze schema. So this is the schema here. We need to load it into a table in the bronze schema. All right, let's do that. So let's create a table, the name or the activity that we're going to do. So this will be bronze layer, right? Now let's create a new node cell, right? A new cell, and give it kind of loading JSON into bronze. So this JSON, we know that the JSON belongs to that will be, the JSON will be for customers, right? Orders table. Over here we can see these are orders batch 1, orders batch 2. So that would be for orders. So orders table in bronze layer, right? Now let's write a code for loading this into the bronze layer, right? So to do that, we'll create a variable. We'll create a variable which is called the bronze orders, and then we load it. We create two variables, one for reading of the files, the JSON files in the volume, that is the landing path that we created, right, in this volume. One for loading that, and the other would be for the table name, the actual table name we will have in the bronze layer for the orders. So let's do that. So let's call this one bronze orders, right? So we are creating a variable equal, what we are going to call is spark dot read, right? Dot. Now if we are reading, if you look at my videos, normally if you are reading something, oftentimes we do dot table, right, with a table name, right, with a catalog this way, dot schema dot table name. Oftentimes that's what I do, right, in my videos most of, if you are reading from a table. But with this, we are not reading from a table, we are reading from a JSON file. So you need to state the format that you are reading from. So we are reading from the format which is JSON, that's JSON dot option. And why do we want option? Now what we are going to look at, if we look at the data, right, there can be instances in this data where we are expecting to have numbers, or we are expecting to have integers, right, or we are expecting to have float or long type. But during the caption of the data, some issues might have gone wrong, and instead of integer, that column or that line was recorded as a string. So you would want to be able to capture that into bronze should capture every data in the database, right? It should move every data in the database, irrespective of the fact that it is the correct data or not. All you need is to capture every single data in there. So we wouldn't want to delete or remove any sort of data from the source. So whatever the nature of the data is from the source in the over here in this JSON file, we want exactly that. And to be able to accept that, we want to tell Spark that even if you see any error with the data, just load it as it is. And that is what we create a column called where you say rescue data column, right? And then you ensure that every malfunction data, it still captures it without deleting. You shouldn't delete any data from it. So to do that, we need to do rescue data column. Rescue data column, right? Then we say you ensure that you give it rescued data this way. So we have this. Then what happens now? We want to load the data. We are telling it that look for all the formats in the particular volume we'll be referring to are in JSON format. When you go there and you find any data that is obviously deviate from the standard you want, don't delete it. Just maintain or keep the data as it is and still load it as it is. That's what this is telling it. And then where is the data? You need to tell Spark where the data is located. So load, and we know we have already created a variable which is loading path, right? Loading path, we already have that. So load, and we know that's a variable outside that, so we need to use an f string, right? So load f string, then you bring your curly bracket, the name is landing path, right? If we go back to our code base, we have it as landing path, right? So that is that. Then when you go to landing path, when we come to landing path here, and we know landing path only ends at the landing folder, right? Volume. So when you come to landing path this way, there are two things that you can find in there. There is the orders and there is the customers. So you need to state which of the folders you are loading from. And in this case, we are loading the orders for this. So we go back and then we state that you load from the orders, right? You load from the orders this way, right? Then you need to, what we are going to do this time around is to add an extra column, right? We want to create an extra column where we'll be able to tell when the date on which we are ingesting this data. When are we moving? If we move this data from here into bronze, we want to state the date on which we moved the data from here. That's the ingestion, right? We are ingesting into this bronze layer. So we want to have the ingestion date as well, right? So what we can do is we have in PySpark, we have with column to create an extra column at the end, right? With column, and you have to give it a column name. So ingested, let's say ingested at, right? Ingested at. And then what happens is we want to give it the current date that we are loading this data, but to be able to call the current date or current timestamp, which is an already defined function or SQL function in Spark, we need to import the PySpark, the SQL PySpark functions, right, into our notebook, right? The SQL PySpark SQL functions, right? And so to do that, we do from PySpark .sql import. You can do it this way: import functions as f. So anytime you call this f function, it calls all the PySpark SQL functions from PySpark, right? You are trying to make use of all the PySpark or SQL functions in PySpark as well. So that is what we are doing here. Instead of us saying call column this like explicitly calling the column function, we don't want to do that. We just want to apply the f over here that we call, which represents all functions, and SQL and PySpark will definitely know that we are calling the column function in here, right? And to do that, we can do f dot current underscore timestamp this way. Now, if this runs, this will create an additional column after it loads into the bronze layer. It would add an additional column called ingested at, and then it will represent the current date on which we run this notebook, right? That's what is going to happen. Now, we also want to get the metadata of this JSON files in this folder, right? The metadata simply means every information about where the data is stored, every nitty-gritty information that we need to know about this loading that we are doing. So we also add that with column, right? And we will name it as source file, comma f dot call, right, column. Then we give the metadata name, which is already inbuilt, metadata dot file underscore path. So this is it. So we've created this variable. Now we need to write this the data into the table, right? Now we have this variable. You can run this. It would create a variable for you. It will create a variable which would be bronze orders, right? We are running this. We can create a new notebook, and we know we are still in the bronze layer. We're still loading the bronze layer, right? While this is loading, what we can do is, ideally we want this to load, but what we can do is to write the function or the code to load the values or the JSON into the file, right, into the path that we have, into this schema, the bronze, and it will also create the table name as well. We will not create that ourselves. It will create a table name for us. So now this variable is created. Now we can see this, how the column, the data will look like, right? This is a data frame. So we see how the data will look like. Great. So we have, you can see the ingested at, which is a timestamp, which will be today's current timestamp, and the source file, which will have a lot of data in it as well. So now with this, we can see the data has still not appeared in the bronze yet schema. It's still in the orders, right, in the landing volume. Now we need to move it into the schema, the bronze schema, with a table name. To do that, what we can do is to create a variable which is the table name. So we can say bronze underscore table equal, right, it's equal to, and we know bakery is the project name, bronze, and so we can say, we can select this, and then we know that to name a table we have the catalog, the schema, and the table name. So this is the catalog name, the schema name. Now we want to give the table a name that we want. So we will say, we can say orders, right? We can say orders, right? What we can give it is orders. Yeah, I think we can leave it at orders, and then we ensure that it meets the standard that we want, right? So others, which is in bronze. Now we know this is a variable that is being created for us. Now let's move the data from this JSON, from the JSON files that we have, which is here, these files. Let's load it into this table that we have here. So to do that, you would call this variable that you have, bronze orders, bronze underscore orders dot write. You are going to write into this, you are going to write this data into a specific location or table that you specified, right? Write, what is the mode we want to write, right? So we want to state the mode should be append. Append simply means it should keep adding, right? Even if it's already exists, you can keep adding or you can replace, right? Even if it doesn't exist, it will create it by itself. Append dot options, option into bracket merge schema, comma, to merge schema true. You ensure that merge schema is true. That is, schema simply means the table headings, right? When it loads, I'll show you what the schema means. It's just the table headings that we have here, right? So this schema, this is schema, this is schema, right? So it's like table column, the structure of the table column, right? At times some tables do change or they vary, right? So you can ensure that the merge schema is set to true. Then you save this data as, you save it as table. So you are saving this specific data that you have in here, you are writing it, and what mode of writing are you writing? You are appending it. So you see sometimes when you bring it here, append is giving you specify the behavior. It tells you the definition or the explanation of how append works, right? This is how it works, right? And then we have the option, how do you want to append it, right? You want to ensure that the schema, even if it changes, you want to add to it, you wouldn't want to delete it. Now, which table are you saving it to which table are you saving it to? We are saving it to this table that you have over here. We created this variable over here, right? Now let's run it and see if our table gets created. If we encounter bug, we'll solve it together, right? So this should write to the table that we have. So it's running, it's creating a job to run, right? You can see it's creating, it's executing this. It has completed. Whoa, great. So this is the size of the data that it wrote. So let's go to the table to see if we'll find the table, if we should find the table name orders in the bronze, right? So if we go here, let's refresh. Congratulations, this is great. Yeah, it did. So if we take a look at the table, let's start the serverless compute. When we start the serverless compute, it has started. We want to take a look at the column. So you can see we have the category, customer ID, order ID, orders timestamp, product quality, status, unit price, ingested at. You see, when we go back, you see we created this ingested at, and the ingested at should be the current timestamp. So it should be current date, right? The date on which this notebook was run. And we also have another column which is source file. Then this should carry the metadata or other detail about the file source and everything, right? So we have file source. So let's take a look at the sample and see how it looks. Great. So you can see this has now, this is the original source. It has source file. So you can see Databricks file source. This is the source, and this is the file that it is coming from. Right, this is the file that it is coming from, and this is the timestamp ingested at. So this is the time we created that. Better still, you could also just use PySpark to view it, right? So you could do, say, bronze underscore data frame equals spark dot read dot table, right? And then grab this table name, which of course, it should be catalog name, schema name, and table name. So catalog name, schema name, and table name. And then you display into bracket to display the data frame. So let's run this, and this should give you the same result as the sample we were looking at, right? This should bring out the data that we have in there. Great. So we have this, and if you take a look at this, if we go back to the landing and look at the orders table, we had two files, one which was on this, and second and fourth. So we expected the write to load both files at the same time. And if you look at the data, you can see that it's loaded both files as well. You can see 04 and 02. So it loaded everything that we had into the table. So now we can see the data very well in a good structure, and you can see some errors with the data, minor negative quantity, null data, and I think the date format didn't also meet or conform to what we had. And yeah, so we can address that later on. But in the bronze, we do not touch it, you just leave it as it is, and then you maintain that. So that's the bronze for you, right? This to load the JSON file, right? Now we're going to load the CSV. We know when we go back to the landing, there are two files in the landing, in the source file, right? In the S3 assumption in this scenario, right? And we have customers, which is also CSV file. So let's load the CSV file as well into a table in the bronze, right? We move that as well into the bronze. So let's create this and also say loading CSV into bronze, which this time around is customers table, right? And the same way we did for the JSON is the same code we're going to write, but this time around the format is going to change from JSON to CSV, which will also have different mode, write mode, right? So let's get that rolling. So you say bronze, let's create a variable as we did, bronze underscore customers equal. Now we know we have to read the file, right? Spark dot read dot. So which file are we going to read? We're going to read from, this time around we're going to read from the customers folder, but it's a CSV file. So if we go back to this, when we were reading this, we said format is JSON, but this time around we are not going to say format is JSON. Format this time around is going to be what? CSV. Correct. CSV. Then we have option. So how is it going to read it? What are the options that in Spark needs to take into consideration when loading it? And if we go back to our CSV file, we know there were headers, right? There were headers in this, and we didn't want Spark to ignore these headers. Let's ensure that Spark notes the headers and uses the headers as the schema level, right? So what we're going to do is say that we tell it that there is headers, right? Header. So what does it do? Header, does it have header? Yes. So true. Header true. So we're telling it that there's a header consider that when loading it and use those headers as well as the schema name or the column names, right? And that's what we call schema, the column names, schema, right? The structure in which it's laid. So when a column changes, that's when we call schema evolution and all that. As time goes, I'm sure I'll do other videos to explain that more, right? And then reloading, of course, we need to load it just like how we did. And we have f string, of course. Yeah, we have London, reloading from where London path, and we have reloading from the customers folder, because this is found in customers folder here, right? If you go back, customers folder, right? Close this. Just as we had, we're also going to ensure that we have an ingested at date. We tell when the ingested at date, right? So to do that, with column into bracket underscore ingested at comma current date, right? F dot current timestamp. But this wouldn't run because we need to still import. Let me see. I think since we imported it, we already imported it, so it should run. Okay, great. It should run. If it doesn't, we will debug it. With column as well, we add in another column which will get the file path, every metadata about the file, right? And we will also give this source file, comma, and f dot call column metadata dot file path. Yeah, so if we run this, it should also create a variable, and then we have another cell to load it. Great. So it worked because we already ran the the import, so it worked. Now let's load this CSV into the bronze layer, right? Let's load this CSV into the bronze layer. So we're going to say bronze customers, right? This variable that we have over here, bronze customers dot write dot, what will be the write mode? How are we going to move the data into this into the targeted table that we want? How should it be done? That's the mode that it's going to ask, right? So the mode of write should be, as we did, append dot option should be mergeSchema, and that should be true, right? Then we have save as. I think we need to create a variable. We need to create a variable which will be the customers table. So we say bronze customer, bronze customer this way table should be equal to. So we know we already created something like this, so I can just copy this, go back here, but this time around won't be orders, it would be customers. Yeah, so we'll say save as table bracket this table. Instead of, why do we do this? It makes it easier for us to understand, make the code shorter, because instead of bringing this here, ideally the whole of this should have been here, should be here this way. And if you run it, it would work, right? It would work, but this makes our code block so long, so lengthy to read. So I just want to make it easier by assigning a variable, this table name, to a variable and calling the variable here, right? And so if I run it, this should create a table in the bronze schema called customers. So you can see this is running and it's successfully done. So if we go back, we should have another table in here, which should be bronze, which should be customers, right? So let's refresh. Great. You can see we have another table in the bronze layer, which is customers, and it has all this column: customer ID, name, email, city, sign up date, ingested at source file as well. Let's take a look at the sample. And this is coming from the CSV file we had in the London volume, right? And this is it. Right. This is what we had. And this is it. Beautiful. Great. And you can also use Spark to view this as we did earlier on. So you can say bronze, you can say customer data frame equal spark dot read dot table bracket open. So this way, and then you display customer data frame. If we run it, you should see the code, right? So we have this. Great. Now we've been able to create a bronze layer. If you go back to our architecture, we've been able to create the bronze layer for our process, right? For this architecture. Now we've been able to load the data into the bronze, and we're keeping them in the original state. Congrats. So we now need to move this data from here into silver, but this time around we are going to do some transformations here. When the data comes here, we'll do some cleaning, we'll do some adjustment, we'll create some things out of the data. That's what we are going to do in the silver layer, right? Great.